increases to 1 plus alpha. Where alpha is?
Sir, length is 1 meter or that is centimeter?
1 meter. Okay. Coefficient of
Length.
Coefficient of linear expansion. So alpha is the coefficient of linear expansion.
Sir, right. Can you repeat the statement full once? It's not clear for me.
This is the first one is the cube. Cube each side is 1 meter. Length 1 meter. Height is 1 meter. So it is temperature is T1 degrees C. So each side is 1 plus alpha, 1 plus alpha, 1 plus alpha. So let us consider a cube of each side is each side of length 1 meter. So its initial temperature is T1 degrees C. This is at T1 degrees C. It is T2 degrees C. The difference of temperature T2 minus T1 equal to at least 1 degree C. The temperature is T1 degrees C. It is heated to T2 degrees C. The difference of temperature is T2 minus T1 equal to 1 degree C. At least 1 degree C. Then each side of cube increases to 1 plus alpha. Length 1 plus alpha, height is 1 plus alpha, breadth also 1 plus alpha. Where alpha is the coefficient of linear expansion. Where alpha is the coefficient of linear expansion. Right? First one, initial length. So L1 is equal to 1 meter. Final length. So L2 equal to length into 1 plus alpha meter. Initial area. A1 equal to L into B. 1 meter into 1 meter. 1 meter square. Next. Final area. A2 equal to 1 plus alpha into 1 plus alpha. So 1 plus alpha square. Meter square. Unit. M is the meter. Unit. Initial volume. So V is equal to LBH. 1 meter into 1 meter into 1 meter. So 1 meter cube. Final volume. So V2 equal to 1 plus alpha whole cube meter cube. So initial length, final length, initial area, final area, initial volume, final volume. So this is the T1 degree C to T2 degree C. Each side is increases 1 plus alpha, 1 plus alpha.
Sir, 1 minute. Sir.
Okay. So first one, a cube. A cube of each side of length is 1 meter. Initial temperature T1 degrees C. It is heated to T2 degrees C. Each side is increased as 1 plus alpha. Length 1 plus alpha, height 1 plus alpha, breadth also 1 plus alpha. So alpha is the coefficient of linear expansion. So all sides are equal expansion. So initial length, initial area, initial length, final length, initial area, initial volume, final volume.
Sir, after solving this, we'll get to the beta gamma in terms of alpha, no, sir?
First, this is the basic. So first relation between relation between alpha and beta. Alpha and beta. Relation between alpha and beta, relation between alpha and gamma, next one relation between alpha, beta, gamma. Right. Right. So first one, beta is equal to A2 minus A1 by A1 into T2 minus T1. So you know that coefficient of aerial expansion beta equal to A2 minus A1 by A1 into T2 minus T1. So beta is equal to, what is the A2? 1 plus alpha whole square. A1 means 1. 1 into 1. Temporary difference 1. A plus B whole square. A square, B square plus 2AB minus 1. So 1 no 1 square cancel. So beta equal to alpha square plus 2 alpha. Okay. Alpha is small. So alpha square is very, very small. So alpha square is eliminated or removed. Or eliminated. Therefore, beta is equal to 2 alpha. Beta equal to 2 alpha. This is the relation between alpha and beta. So B, relation between alpha and gamma. So gamma equal to V2 minus V1 by V1 into T2 minus T1. What is V2? Final volume. So V2, 1 plus alpha whole cube minus 1 by 1 into 1. Okay? So 1 plus 1. What is the A plus B whole cube?
A square plus B square plus 2.
Be a whole cube. A cubed plus B cubed plus BA square.
3AB square.
This is the formula. So gamma equal to 1 cubed alpha cubed. So 1 square alpha, 1 alpha square minus 1 by 1. So 1 cubed 1 cancel. Gamma equal to alpha cubed plus 3 alpha plus 3 alpha square. If alpha is small, alpha square and alpha cube are very, very small. So these two values, so alpha square and alpha cube are removed. So therefore gamma equal to 3 alpha. So beta is equal to alpha, gamma equal to 3 alpha. See. So relation between.
Sir, it alpha square ni alpha cube ni 0 anukunnam kada sir?
0 gas eliminated, removed.
Yeah, almost.
Small and alpha, beta and gamma. Is very small, very, very small values. For example, alpha value 0.001, for example, 0.01. Alpha square, so 10 power minus 4 or 5. For alpha cube is 10 power minus 8. So very, very small values, neglected. So approximately 0. So alpha, beta and gamma. Relation between alpha, beta and gamma. Alpha is to beta is to gamma equal to alpha, alpha. Beta means 2 alpha. Gamma means 3 alpha. So alpha, alpha cancel. So 1 is to 2 is to 3. Part A, alpha and beta relation. Part B, alpha and gamma relation. C, alpha, beta, gamma relation.
Sir, exam direct ask us, sir, 1 is 2 to 3.
So next to prove, next revision program also prove. Another method is there. Simple method, actually. Tell me now.
Sir, exam direct ask us, sir, this relation.
No. Write down. Proof IP question actually. Define alpha, beta, gamma and deduce the relation between them. 4 marks question. But not important. Actually 4 marks question.
Sir, over sir, weekend syllabus?
One topic is there, Rana. Okay. Next. Relation between alpha, beta and gamma. Beta and gamma. We know that beta equal to 2 alpha. Alpha equal to beta by 2. So gamma equal to 3 alpha. Alpha equal to gamma by 3. From 1 and 2, from equation 1 and 2. So beta by 2 is equal to gamma by 3. Beta equal to, so 2 by 3 into gamma. Or gamma equal to 3 by 2 into beta. So relation between alpha and beta equal to alpha, relation between alpha and gamma. Gamma equal to 3 alpha. So alpha is to beta is to gamma is 1 is to 2 is to 3. Relation between beta and gamma. Beta equal to 2 by 3 gamma or gamma equal to 3 by 2 of beta. Okay. Next one, applicants of solids. So first one, let alpha x, alpha y and alpha z be the coefficient of linear expansion, along x, y and z axis. Alpha x, alpha y and alpha z is the coefficient of linear expansion along x, y and z axis. X, y and z axis. X, y and z axis. Right. X, y and z axis. Next one. So then gamma is equal to alpha x plus alpha y plus alpha z. So alpha gamma means cubical expansion, length to breadth. This is the length, this is the breadth, this is the height. Gamma equal to alpha x plus alpha y plus alpha z. So beta is equal to. Now what is the beta? So beta is equal to 2 by 3 into gamma. So that equal to 2 by 3 into gamma value alpha x, alpha y, alpha z. See, alpha is equal to gamma by 3. So 1 by 3 into alpha x, alpha y, alpha z. So gamma equal to alpha x plus alpha y plus alpha z. Beta equal to 2 by 3 into alpha x plus alpha y plus alpha z. And gamma alpha equal to 1 by 3 into gamma, 1 by 3 into alpha x plus alpha y plus alpha z. Okay.
Sir, can you move aside?
Sir, this is only one exam application.
Right. So second one, beta is equal to 2 alpha, gamma equal to 3 alpha. Right. Gamma equal to 3 alpha. So that equal to gamma equal to alpha plus 2 alpha. So on alpha plus 2 alpha, or gamma equal to alpha plus beta also. Gamma equal to 3 alpha, gamma equal to alpha plus 2 alpha, or gamma equal to alpha plus beta.
సార్ ఇలా 20 ఉంటాయా సార్? సార్ ఇలా 20 ఉంటాయా అప్లికేషన్స్?
20 ఉంటాయి. యాక్చువల్ 20 అప్లికేషన్స్ సాధ్యం.
ఇప్పుడు ఎగ్జామ్
సార్ మీరు ఎగ్జామ్ ఒకటే అని చెప్పారు కదా సార్.
ఓన్లీ వన్
అంటే ఓన్లీ ఇక్కడ వరకేనా సార్?
ఇంకో అదే చెప్తాను. వేరియేషన్ ఆఫ్ డెన్సిటీ విత్ టెంపరేచర్.
సార్ ఒకసారి ఫస్ట్ దాంట్లో బి ఇంకా సి ఒకసారి చెప్తారా సార్? ఫస్ట్ బిసి
ఆల్రెడీ ప్రూవ్ అబ్బాయి రిలేషన్ బిట్వీన్ బీటా అండ్ గామా.
ఓకే సార్.
బీటా ఈక్వల్ 2/3 గామా వాల్యూ సబ్స్టిట్యూట్. సో ఆల్రెడీ ప్రూవ్ గామా ఈక్వల్ 3 ఆల్ఫా, ఆల్ఫా ఈక్వల్ టు గామా/3.
ఓకే ఓకే.
Right. So third one is variation of density. Variation of density with the temperature. So variation of density with the temperature. The last topic for weekend syllabus. Variation of density of a substance with the temperature. Variation of density with the temperature. A volume of a solid increases on heating while its mass remains constant.
Density increase.
Mass constant.
Density decreases.
Increases solid. The volume of a solid increases on heating while its mass remains constant. Mass constant. Right? Mass constant means density equal to mass by volume.
Increases.
Inversely proportional.
So density equal to mass by volume. So mass equal to M equal to D by D is equal to density denoted dr rho M by V. So M equal to dV. So VDR dV. Mass equal to density into volume. Density changes from D1 to D2, volume changes from V1 to V2. If density changes from D1 to D2 and volume changes from V1 to V2 for or at the constant mass, for constant mass. Okay, right. So therefore D1 V1 equal to D2 V. But V2 is equal to V1 into 1 plus gamma. So T2 minus T1. The temperature increases from T1 to T2. If the temperature increases from T1 to T2. Right. So D1 V1 equal to, so D2 into V1 into 1 plus gamma T2 minus T1. So V1 cancel. So D1 equal to D2 plus D2 gamma T2 minus T1. So D1 minus D2 is equal to D2 gamma into T2 minus T1. So therefore, gamma is equal to D1 minus D2 by, so D2 into, so T2 minus T1. So gamma equal to D1 minus D2 by D1 in D2 into T2 minus T1. Let D0 and DT and D0 be the density at T degree C and 0 degree C. Then gamma is equal to, so 1 minus initial D0 minus DT by DT into T minus 0. So in this case, so density is decreases with increase of temperature. With increase of temperature. So D0 is high density and 0 degrees density is more. So DT is the temperature density at T degrees is decreases. So initial without any heating, density is high. So water is heated, so density also decreases. D0 minus D. Okay. So density decreases with increase of temperature. Density decreases with increase of temperature. This is a very, very, very important formula. So D0 is the density at 0 degree C. DT is the density at T degree C. So T is the temperature. So then coefficient of cubical expansion gamma equal to D0 minus DT by DT into T minus 0. For example, DT given, D0 given, find the coefficient of linear expansion calculated. First gamma calculated, gamma equal to 3 alpha equal to gamma by 3. For example, so alpha equal to gamma by 3. So after gamma calculated, next one alpha equal to gamma by 3. So dividing by 3, it changes to alpha, linear.
Sir, erase చేయకండి sir.
సార్ ఎంతేనా సార్ పోర్షన్?
Up to this one syllabus.
Sir, can we write alpha is equal to 3D0 minus 3dd by dd into t minus 0?
This one,
Yes, sir. Gamma place.
So what is the D1, D2? D1, what is the D1? Initial density. What is D2? Final density. So D2 and D0 be the density at 3 degrees and 0 degrees C. D1 means initial. This is also D0 is the initial. So D0 minus DT by DT.
No, sir. Quotient of linear expansion అడిగినప్పుడు డైరెక్ట్ గామా వాల్యూ ఈ ఈక్వేషన్స్
Gamma calculated after that alpha equal to gamma by 3. First gamma calculated. For example, beta calculated. So beta calculated means same previous one 3 by 2 into
alpha by beta.
first gamma calculated. Gamma means in terms of this is the formula. D naught minus dt by dt into t minus 0. First gamma calculated, after that anyone. For example, alpha calculated gamma by 3. Beta calculated 3 by 2 into gamma. Density decreases with increase of temperature. Very, very important formula. Gamma equal to d naught minus dt by dt into t. So d naught minus dt is equal to gamma dt into t. So d naught equal to dt plus gamma dt into t. D naught equal to dt common 1 plus gamma t. Or dt is equal to d naught by 1 plus gamma t. So according to binomial theorem, dt equal to d naught into 1 plus gamma t whole power minus 1. What is the binomial theorem? 1 plus x whole power n equal to 1 plus nx. Binomial theorem. So according to binomial theorem, completed. So therefore, dt equal to d naught into plus into minus minus 1 minus gamma. There is some substance contracts on heating. Some substance contracts on heating. What is some substance contracts on heating?
Water.
Pure water from 0 degrees C to 4 degrees C, Indian rubber, cast iron, silver iodide, silver iodide, silica glass. So these substance, contracts on heating. Okay. Right done. Fourth application. Substance substances which contracts on heating are A. Is a cast iron. B. So Indian rubber. So
Which
Indian
one,
rubber.
sir? Indian rubber means?
Rubber, general rubber.
Okay, sir.
General rubber.
Sir, is it sir?
So grown in India.
So Indian rubber. C. Indian rubber. Type metals. So D. Silica glass. E. Silver iodide. F. Gallium. G. Bismuth.
Sir, what is C?
Ice.
Sir, C.
Type metal is the welding up of some type of metals. Silica glass, Indian rubber, ice, A, B, C, D, E, F, G, H. I, lead. Ice are J. For pure water from 0 degrees C to 4 degrees C. 0 degrees C to 4 degrees C. So this is the contracts on heating. Contract and heating. So it is it decreases. So cast iron, Indian rubber, type metal, silica glass, silver iodide, so gallium, bismuth, ice, lead for pure water from 0 degrees C to 4 degrees C. This is actually anomalous expansion of water. For pure water is heated from 0 degrees C to 4 degrees C. Is contracts from 4 degrees C to on 100 degrees C. 100 degrees C expands. On heating only. On cooling reverse. 100 degrees C to 4 degrees C contracts, 4 degrees C to 0 degrees C expands. This phenomenon is called anomalous expansion of water.
Sir, thermocol sheets are there, no sir? Thermocol sheets. Thermocol sheets, sir.
Thermocol sheets, maybe.
Sir, leather? Leather?
Leather, rubber, same.
Okay, sir.
Exercise 1. Exercise 1. This is a 57, very, very important, 57.
Can you read the question, sir?
A cylindrical metal rod.
Cylindrical metal rod of length L naught.
Right, a cylindrical, right. Exercise 1, 57. A cylindrical metal rod is also PDF is there, huh?
Yes, sir.
Right, this is the X. So next one, this is the R radius. This is the D. A cylindrical metal rod of length L0 and is shaped into a ring with a small gap as shown in the figure. On heating the system,
All will increase.
all are increases. All.
Expansion of solid.
So X, R and D all increases. Because flame passing through, for example, this one, this is also expand. This is the halo, they also expand. This the halo means in between them air is removed. This is also halo spheres. So they also it is easy to expand. So all are expand. R, X and R and D all are expands. All are increases. Option 3 is correct.
All will increase, sir.
All are increases.
Okay.
Fifth one, relation between alpha C and alpha F. Alpha C and alpha F.
Sir, syllabus అయితే అయిపోయింది కదా Sir, weekend syllabus is over now, sir. We are just
over,
continuing.
but in case.
Okay, sir. Okay.
In case. Right. Relation between alpha C and alpha F. Alpha C and alpha F. So alpha C and alpha F. Next application, fifth application. Relation between alpha C and alpha F. Generally, delta C by 5 is equal to, we know that. So delta C by 5 is equal to delta F by 9. But alpha is equal to L2 minus L1 by L1 into delta T. Delta into L delta T. So this is that equal to delta L by L into delta T. This is the change in length. Dimensionally cancel. So alpha is proportional to, so 1 by delta T. For example, centigrade scale. So delta C is proportional to 1 by alpha centigrade scale. So delta Fahrenheit is equal to 1 by alpha F. So this is the equation 1, equation 2, equation 3. So equation 2 and 3 substitute in equation 1. In equation 1. What is the delta C? 1 by alpha C into 5 is equal to what is delta F?
Delta F minus 32 కాదు.
So 5 alpha C equal to 9 alpha F. So alpha C equal to 9 by 5 alpha F, or alpha F is equal to 5 by 9 alpha.
Sir, delta F minus 32 by delta F
change in temperature, difference of temperatures. One formula there are delta C by 5 equal to delta F by 9 equal to delta K by 5 equal to delta R by
different.
Previous class notebook. So this is the relation centigrade and alpha C and alpha F, or alpha F equal to 5/9 into alpha C. One value given, alpha F value given, alpha C calculated. For example, alpha C value given, alpha F calculated. Maybe workbook one problem or exercise one. Exercise one or workbook.
Once read the question, sir.
Okay. Exercise one is not there. Maybe workbook. I don't know.
So exercise to 127 page, 12th question, sir.
Exercise
To 127th page, 12th questions.
no. 12th question, okay, direct.
Same, this problem only, sir, relation.
Right, this problem is correct. Coefficient of cubical expansion of solid is 0.5027. The temperature is measured by Fahrenheit. Right, correct. So direct substitute and simplify. Exercise 2.
Sir, option 2.
57. Okay. 13th problem. The coefficient of cubical expansion is x times coefficient of superficial expansion. Then the value of x is
1.5, sir.
Superficial expansions.
Sir, 1.5.
Coefficient of cubical expansion is x. X times the coefficient of very important.
So superficial expansion, sir.
Area
Superficial. Area by already note chevanu you know class.
Aerial.
Aerial expansion. Superficial means aerial expansion. Right. So if the cubical expansion is exercise 2, problem number 13. The coefficient of cubical expansion gamma equal to x times of coefficient of superficial expansion is beta. So then the value of x is.
Sir, x is 3/2, sir?
Maybe.
That is 1.5.
Only 1.5, sir.
So relation between, we know that
Gamma is equal to 2/3.
gamma equal to 3/2
By
into
2,
beta.
yeah.
This is the given, this is the equation. Comparing the equation 1 and 2. X equal to 3/2. So that equal to 1.5.
Sir, can you tell 23rd question, exercise 2?
23rd.
Yes, sir.
Yes, sir.
The steel rod dimensions 4 into 4.
Yes, sir, that one.
Yes, sir.
Stress, thermal stress, not this week. Thermal stress, thermal force and thermal stress. So F by A is equal to Y
Sir, not there, sir, this week.
Y alpha delta T. This is the thermal stress. Not this week. This is the application next week.
Okay, sir.
Sir, even 31st question.
Thermal force. F is equal to Ya alpha delta T. This is the thermal stress. This is the thermal force. Write down one concept or workbook. Refer workbook. The diameter of a metal ring is capital D. The diameter of a metal ring is capital D. Refer workbook run. The diameter of a metal ring is capital D.
Sir, level 1.
And the coefficient of linear expansion is alpha. And the coefficient of linear expansion is alpha. Full stop. If the temperature of the ring is increased by 1 degree C, if the temperature of the ring is increased by 1 degree C, then the increase in circumference of the ring, circumference of the ring, maybe sixth application 6A. Workbook problem is there, workbook? The diameter of a metal ring is D and the coefficient of linear expansion is alpha. If the temperature of the ring is increased by 1 degree C, so delta T equal
Radius
to
is
1.
equals to 1 plus alpha.
Then the circumference of the ring is, right, circumference of the ring. Circumference of the ring. Okay? Right. Ring delta L equal to L alpha delta T. L alpha delta T. Right. What is the L? So this is the ring, circumference of the ring, radius is R, 2 pi R. 2 pi R into alpha delta T. So 2 pi into R is equal to D by T. D is equal to 2R. So R equal to D by T. So D by 2 into alpha, temperature difference 1 degree C. So 2 cancel, pi D alpha. So circumference of the ring is pi D alpha. Same on B, another bit. B.
Area, sir.
Right. Area. Right. The diameter of a metal ring is D.
Muted, sir.
Diameter of a metal ring is D. And coefficient of air expansion is beta. If the temperature of the ring increased by 1 degree C,
20.
if the temperature, write down by workbook, write down. Don't waste time.
Coefficient.
If the temperature of the ring, the coefficient of aerial expansion is beta.
So once again, say the question, sir. So once again from starting, say the question, sir. Second question.
Starting. By enduka by time hechasavu. The diameter of a metal ring is D. The diameter of a metal ring is D. The diameter of metal ring is D. And the coefficient of aerial expansion is beta. And the coefficient of aerial expansion is beta. If the temperature of the ring is increased by, if the temperature of the ring is increased by 1 degree C, if the temperature of the ring is increased by 1 degree C, then increase in area of the ring. Increase in area of the ring. So area of the ring calculated. So delta A is equal to A beta delta T. A beta delta T. Beta equal to delta A by A into delta T. Delta equal to A beta delta T. So So beta equal to delta A by A into delta T. Right. So delta A is equal to, what is A? A is the pi r square. Pi r square into beta into delta T. So D is equal to 2R. So R equal to D by T. D by 2 whole square into beta into 1. So pi D square beta by 4. So delta A equal to. Or in terms of alpha, so pi D square by 4 into beta means 2 alpha. 2 1 are 2 2 are. So delta A is equal to
pi d square alpha
by 2. In terms of alpha by 2, in terms of beta 4.
Sir, time up, sir, 10:32.
The 22 important, 22 problem. Okay, na? The density of substance at 0 degrees C is 10.6 gram per cc and 100 degrees C is 10 gram per cc. The coefficient of linear expansion of solid 22. Correct. Gamma equal to dt minus d naught minus dt by dt into t minus 0.
Direct sir.
Okay, 22 now.
Exercise 22 also.
Exercise 222.
Okay.
Okay? Why not?
Must